So next is hydrostatic lubricant. It is similar to the hydrodynamic lubricant what we have seen, but here, so in hydrodynamic lubricant, the pressure of the lubricant is increased by the rotation of the shaft or by the speed of the shaft. Based on the rotation of the shaft and load acting on the shaft, the pressure of the lubricant increases. That makes the separation between the shaft and the bearing in the hydrodynamic lubrication. But in hydrostatic lubrication, what will happen? So here, before we are going to send the lubricants in between the shaft and the bearing, we are going to increase the pressure of the lubricant with the help of the oil pump. And sure. So by with the help of the pump, we are going to increase the pressure of the lubricant. That pressure, that pressurized oil, we are going to place in between the shaft and the lubricant. That pressurized oil make the separation between the shaft and the bearing. That process is nothing but hydrostatic lubrication. So next we will see boundary lubricant or thin film lubricant. It is nothing but it is simple. Already there is a lubricant. If you see here the figure, already there is a lubricant in between the two component. At some point there is a contact between one component to the another component. At some point there is no contact. If you come to the another, at that another point there is a contact. So if you consider another point, there is no contact. So that is nothing but in between the two components there is a thin film. Thin film of lubricant is present. So that we will call it as boundary lubricant or thin film lubricant. Even though there is a lubricant in between the two component, there is a contact between the there is a contact between one component to the another component at some point. That is nothing but boundary lubricant or thin film lubricant. So this boundary lubricant happens when a shaft moves, a shaft start moving from rest. The speed is very low, the load is very high, viscosity of the lubricant is very low. So due to these reasons, the boundary lubricant will takes place. So even though there is a lubricant, there is a contact between one component to the another component. That process we will call it as boundary lubricant or thin film lubrication. Next is nothing but extreme pressure lubrication. That is nothing but when a moving component or a sliding surfaces are under high pressure and speed. For example, if you consider a moving component or sliding surfaces having high pressure and high speed, if there is a high pressure and high speed between the moving and the sliding surfaces, high temperature will be developed. And sure, some temperature will be developed between the moving or sliding surfaces. So in order to reduce this temperature, we can't use the liquid lubricant. The liquid lubricants fails to reduce the temperature when there is a high temperature due to the high pressure and speed. So in order to overcome this problem, we are going to use some additives. See, we are going to use some special additives to the oils in order to reduce the extreme pressure or in order to reduce the highly localized temperature. And sure. So that is nothing but in order to reduce the high temperature generated between the two moving or sliding surfaces due to the high pressure and temperature, we are using some additives in the oils. So with the help of those additives, we can able to reduce the temperature between the two components. So that process is nothing but extreme pressure lubrication. So some of the additives like chlorine, azan, chloride ester, sulfur and the phosphorus. So these are the some of the additives we are going to use to the oils in order to increase the pressure of the oil or in order to reduce the temperature of the moving or the sliding surfaces. That process is nothing but extreme pressure lubrication. Okay. So these are the four different types of lubrication. One is hydrodynamic or thick film, we can call it as, or hydrostatic lubricant, boundary lubricants or thin film lubrication, and extreme pressure lubrication. And sure. Next we will see terms used in hydrodynamic journal bearing. Now we are using the hydrodynamic, first one, hydrodynamic journal bearing. So now if you see the figure, so this is the shaft, or we can call it as journal. This is nothing but bearing. And sure, now we will see, let capital D is equal to diameter of the bearing, and should small d is equal to diameter of the journal. So whatever thing you are seeing, this is nothing but capital D, and small d is nothing but the diameter of the journal. L is equal to length of the bearing. And sure, now we will see, now you can see, if you see these two, this is figure, the center of the journal and the center of the bearing is not coincidence. And sure, so this is the center for the bearing and this is the center for the journal. So due to this, we will get the eccentricity E. And sure, the center of the journal and the center of the bearing are not coincidence. It is having some distance. That distance we will call it as E, where E is nothing but eccentricity. And sure, now we will see first what is diametrical clearance. It is denoted by C, that is equal to D minus D. That is nothing but the difference between diameter of the bearing to the diameter of the journal is nothing but diametrical clearance. And sure, it is the difference between the diameter of the bearings and the journal is called as diametrical clearance. That is capital D minus small d is equal to diametrical clearance. Next, second one, what is radial clearance? Said the difference between the radius of the bearing and the journal is called it as radial clearance. It is denoted by CR, that is nothing but capital R minus small r. Difference between radius of the bearing and the journal is nothing but radial clearance. Next we will see what is diametrical clearance ratio. And sure, it is the ratio of diametrical clearance to the diameter of the journal. That is nothing but C divided by small d. We have discussed C is nothing but diametrical clearance. The ratio of diametrical clearance C divided by the diameter of the journal is nothing but diametrical clearance ratio. Or we can write it as C is nothing but capital D minus small d divided by small d. And sure. Next we will see eccentricity. Already I told that eccentricity, the distance between the center of the bearing to the center of the journal is nothing but eccentricity, and it is denoted by small e. And sure, the radial distance between the center of the bearing and the center of the journal is nothing but eccentricity E. Next is minimum oil film thickness. It is the minimum distance between the bearing and the journal under complete lubrication condition is nothing but minimum film thickness. That is nothing but the minimum distance between the journal and the bearing when there is a complete lubrication, that is nothing but minimum oil film thickness. That is nothing but, if you see this figure, in this complete figure, see, if you see here, there is a large distance between bearing and the journal. If you come to this point, there is a small distance between journal and the bearing. So it is nothing but minimum oil film. So where there is a minimum distance between the journal and the bearing, this distance we will call it as minimum oil film thickness. That is the minimum distance between the bearing and the journal. And sure. So these are the some of the notations we are going to use in the hydrodynamic journal bearing. One is diametrical clearance, radial clearance, air material clearance ratio, eccentricity, and minimum oil film thickness. Understood?